Hey guys, happy Friday. So I am not here. I'm up at the school right now. It's Thursday night. I wasn't at school today, won't be at school tomorrow. I don't have COVID 19. I have come down with mono, and so I'm just at home resting. Hopefully, we'll be back Monday and feeling better to be able to come back to school, but just getting home, getting some rest. But I wanted to come up to school and make sure to record lesson 2.1 and do a couple pages of notes for y'all so that we're not getting behind. And we'll go from there. So talking about chapter 1 though real quick, that first test, the scores are in. You should be able to go back through and click view and look at your test, I think. If not, we can fix it on Tuesday when I see y'all again. And on Wednesday next week, we're going to take some time and go through the test and talk about some common errors and fix our mistakes so that we can move on. So we're going to do, hopefully y'all are, if you're watching this, hopefully you're at school you got the notes from the sub. If not, the notes packets are on my desk, but they're also online in the notes folder of chapter 2. So we're going to do notes today, and then there is 2.1 homework is due on Tuesday, and we're going to do a quiz on Tuesday. We'll take the first bit of class to answer questions and anything you need, and then we're going to do some notes after that. So don't really want to miss out on a day, so want to make sure that we're getting this lesson recorded. Unfortunately, these are pretty good for y'all to. This would have been a good one where y'all would have been kind of going through them, kind of seeing what you already know, or just good. These are some good lessons to you to kind of go through, and then me to go on the backside of it. So with that, you can either watch this straight through and just watch me do the lesson, and I'm just going to fill it out and explain everything. But if you want, you can pause and try and work ahead and do it yourself, and then watch me do it on the video. Either way. So I'm going to do both lessons, 2.1. So the first one is where do I stand, and then the second one is how did I do. The major things on these are percentiles. We talk about cumulative frequency, and we introduce this huge thing for statistics called a z-score, a standardized score. So we're going to talk about that, and so that'll be through the next lesson here. So why don't I just go ahead, get started, see what we're doing. So on this first one, describe the distribution. Anytime you're given a distribution and you're trying to describe it, I need to be doing sock feet. So you are just going through that. So you could say, so you could say the shape of the heights, because that's what we're talking about. So there's my context. So the shape of the heights of the 20 AP Stat students is symmetric. And you could also say, I didn't really talk about this one, which I should have. So this is pretty symmetric data, and then how it's got kind of a little hump there on the symmetric. So because it has two humps, you could also say that is symmetric and bimodal. So bi meaning two. So you could say that. So this shape of the distribution of the students is symmetric and bimodal. It looks like there are outliers at 56 and 57. So there are outliers 56 and not 57, 78, I mean. So I actually want to talk through that because getting an outlier was something of a problem on the test. And so just want to remind us of that. So the first thing we have to do on the outlier, like on the test, it talked about the 1.5 IQR rule. So the interquartile range is the range from the Q1 to Q3. So our IQR on this one would be 4.5. So what I'm going to do is I want it to be 1.5 times bigger than 1.5 or than 4.5. So grabbing the calculator, seeing what it says. So 1.5 times 4.5 is equal to 6.75. So what I'm going to do with that 6.75 is that I take it from the Q1, and if I am less than 6.75 from the Q1, and then I also go from the Q3 and I add 6.75 that way. So if I am any number outside of 65.5, so 65.5 minus 6.75. So if I am outside of 58.75 and then also outside of 76.75. So any number greater than those two, which on our graph, those are those two outliers, those are when those would be considered outliers. So that is that 1.5 IQR rule. I take the interquartile range, I multiply it by 1.5, and then I subtract it from the Q1, add it to the Q3. So there were two outliers, and just looking at the graph, it actually doesn't look like those two are that big of outliers, but because they are a certain distance away from like our middle 50%, that middle IQR, they can be considered outliers. So there's two outliers. Since we're symmetric, so I'm going to go back to this description. So there's outliers. Since we've got symmetric data, I'm going to talk about the mean. So I would say there are outliers. Maybe I'll just write down here and erase it. So I would say the center is the mean of 67.45 meters, inches, those are inches. And then you could either say range or standard deviation. So maybe I'll just use standard deviation right there, and I'll say, and as a standard deviation of 4.807. Man, some bad handwriting. 4.807 inches. Okay, so that is number one. So going through SOC-V, the shape is symmetric and bimodal. There's two outliers at 56 and 78. The center is a mean of 67 with a standard deviation of 4.8. And so the standard deviation is saying we, on average, our distance from our mean is about 4.807. So that's just on average. So like here's our 67 number, and it's just saying on average we are about, plus and minus 4. It doesn't mean all of our data is within there. It just means like most of it is a certain amount. We're actually going to get to how much is within one standard deviation. Okay, so I'm going to erase that one so I can do number 2. So number 2, Ariana is 65 inches tall. So this dot, if I erase, this dot right here is her. What percentage of the heights are less than 65? Okay, so are less than, or this is actually an old one, so it should be less than or equal to 65. So I'm actually going to check y'all's notes because my key is off. Okay, so the notes I printed out for y'all, the College Board switched the definition of this on us last year actually. So these notes need to be updated, but what percentage of the heights are less than or equal to 65? So from her at 65, there is 1, 2, 3, 4, 5 less than her, and we said that there were 20 AP Stat students. So 5 out of 20 are less than or equal to her. So that is like a quarter, so that's like 25%. Okay. What is your height? And so my height actually fits on this. So I would say, I'll just say I'm 73 inches here. So there I am. What percent of the heights are less than or equal to your height? So what percentage is less than or equal to that height? So less than or equal to all the dots less than or equal to that. Well, there's only one dot greater than, and there's 20, so that had to mean there were 19 out of 20 for less than or equal to my height. And I believe that that is like 95%, 0.95. Okay, so what this definition is, the percent that is less than or equal to your number. So this percentage that we're getting, that definition for statistics, is a percentile. So instead of saying 25% are less than or equal to Ariana, we could say that she is in the 25th percentile. And that I have a height of 73 inches, and that is 19 out of 20. So that could be told that I am in the 95th percentile. Okay, so that just means I was really high. I was above most other people on that data plot for the percentages. So like a common one that they use percentiles on, percentiles are used like on your SAT or PSAT scores when you get them back. I remember getting percentiles back and like our friends being like, oh, what percentile are you in? Or like recently, like when Ellie or Joanna goes to the doctor, they get their height and their weight. And so like Ellie is in like the 75th percentile for her age girl's height, and she's like 40 percentile weight. And like Joanna's 25th percentile on everything. She's kind of small. So percentiles are just what are the percent of less than or equal to the value that you've got. So that's one thing on this unit. It's important. So a percentile, if it's asking you what that is, that's just the percent of the data less than or equal to. Okay, this other thing we're going to talk about is cumulative frequency. And so it just goes with our quantitative data. It's just another way to graph it. And so I'm actually if you've watched the news during the COVID-19 stuff, a lot of places are using cumulative frequency graphs as their data, which is sometimes good, sometimes bad. There's just different times to use it. But here we go. So like here is a histogram of that same data from up top. So we took our data and said, in this range there's 1, in this range there's 3, in this range there's 9, in this one there's 6, and in this one there's 1. So just looking at the frequencies over here, I can see that. So the frequency 1, 3, 9, 6, and 1. So frequency is our counts. So this was like first lesson of statistics from the year. So frequency is counts. Relative frequency is the percentages. So just making this is what percent. So 1 out of 20 is 5% of the data. So then I'll just do this. So the frequency is, I just think I got something wrong here. I didn't. That looks right. Sorry about this. Okay, never mind. So then I got, I think this is all adding up, right? Let me see. So 4, 10, yeah, that's right. Okay, so then you got 3 out of 20 is 15%. 9 out of 20 is 45%. 6 out of 20 is 30%, and 1 out of 20 is 5%. So then that's our relative frequencies, and then a cumulative relative frequency is it's cumulative as we keep going. We're adding on top of what we've already done. So if your teacher in whatever class is doing cumulative tests throughout the year, that just means on every single test throughout the year, you will be tested from chapter 1 stuff all the way to chapter 10. So cumulative just means it's all being stacked on top of each other. It's all being added up. So the cumulative relative frequency, so we would start at like 0. So at this point, I have 5% after I've done this dot plot, or this little box here of the histogram. Once I get to the 60 to 64 inches height category though, I add 15% of people to the 5, and cumulatively I have 20%. So I added that relative frequency of 15. Now I have a total of 20% of the data is taken up. When I reach this category of 65 to 69, now I have 20 plus 45, 65% of the data is taken up cumulatively. And then going on, I would add another 30%, so 95% of the data is taken up before I reach this last category. And then once I add them, it makes sense that then 100% of the data is accounted for because this is all of my data. So at the end, I am at 100%, and I'm like starting at kind of a 0 up top, and it goes down, and I start adding. So cumulative frequency is we're combining on top of previously like lesser data, or it could be like by year, by month, whatever, by unit, you're adding on top of it. Okay, so number 4 is use the information in the table to create a cumulative relative frequency graph below. So what I'm going to do is I'm going to have the cumulative relative frequency over here, and I'm going to list it starting at 0%, and we're going to go all the way up to 100%, or you could even say like, you could go in decimals like 0.1, 0.2, all the way up to 1, but maybe I'll just go 100% here. Okay, so I got 100, and then I can go up by any tick mark that I want. So maybe I'll go by 20, so 20, 40, 60, 80. So those are representing the percent of the graph that's taken up. Then on my X's, I'm actually going to do the same categories that I did throughout. So I've got the histogram there. I'm going to have height in inches, like we've been doing with this same data. And what I'm going to do is I'm going to list the same little checkpoints that we went through here. So from 55 up to 80. So it'd be like 55, 60, 65, 70, 75, and 80. So I'm starting there, and if I'm making a cumulative relative frequency, like up until this first mark, I am at 0%. So I like have nothing written here. I don't have to even make a line there. But then when I reached that 55, from 55 to 59, I went up 5%. So when I get to 60, I want to have gone up to about 5% if the smartboard will be accurate enough for me. It's not really reading it right, but I went up 5% in this little marking from 55 to 60. By the time I reached the 60 to 64 category, I was up to 20%. So then there's a little steeper increase there. By the time I reached that 70 number, for the 65 to 69 inches category, I was at 65%. So I'm gonna roughly try my best on this smartboard, and there's another increase. And then from 70 to 74, I went to 95%, so I'm almost at the top there. And then by the time I reached 80, I was at 100%. So that would be my cumulative relative frequency. So these are my percentages total that I've done, and those are my heights on the side. What these do, so why we did percentiles and cumulative frequency graphs go together, because what a cumulative frequency does is it adds up all the values that you were at or less than. So really all of these cumulative relative frequencies are basically your percentiles that you would be calculating. So when you're doing a cumulative relative frequency graph, it just shows the percentiles in a pretty easy way, which we'll go through. Okay, so let's look at just a few more things before we answer A and B. So on this cumulative frequency graph, I didn't go up a lot, I went up more. I had a section where I really went up a lot, and then I didn't, and I slowed off again. So basically what that means is kind of a note for yourself. Like on this little section here, when I went up a lot, I went up really quickly. So kind of when you have a steep slope, what that is indicating is that we had a lot of values there. So if you have a steeper slope in that little data range or whatever, you had a lot. Anywhere that kind of has a smaller slope, we had less frequency. So you can see we had less frequency at the beginning and end, and those slopes are pretty small. And then we got bigger and we got steeper through the middle of the graph. Okay, so let's see. A, Miss Gallus is 66 inches tall. Estimate and interpret the percentile she is at using the graph. So we could use the dot plot up at the top of the page, but we can also just get an estimate. So a cumulative frequency graph can just give us a best estimate for these percentiles as well. So Miss Gallus is at 66 inches tall. So what I'm going to do is I'm going to go to 66 inches tall down here at the heights category, just to the best estimate that I can. And what I'm going to do is I'm going to go up to the point on my graph, so that's about here. And then to get an estimate of where I'm at, I just want to go straight over and see where is that frequency that she is at. So I went up from her 66 and then hit my graph, and I'm going to go over to the left, and that's roughly between that 20 and 40. So what I'll just say is I'm just going to estimate, maybe I'll use the little squiggly there, which means about. So maybe I'll say she is in the 30th percentile, or that means about the 30th percentile. And a big thing that we're going to talk about, so we estimated it, that would be like a check. And if it says interpret, that means give a sentence for what that means. So what does it mean that she is in the 30th percentile? So if I was to interpret that, that would mean that 30% of the students are her height or below. So that would be the interpretation. So anytime it tells you to estimate and interpret, that would be like give an answer, and then interpret would be give a kind of sentence justification of what you mean. So percentile meant 30% of the students are at or below her. Okay, so B would be the opposite. So B is estimate and interpret the 80th percentile. So to the best of my ability, my graph isn't necessarily the best thing I've ever drawn. It's actually pretty off, but here's 80. So this dot here was supposed to be at like 65%. That's where that is. So I need to at least be above that because that was supposed to be 65%. So 80, I'm going to roughly go straight over to my graph, which would be there, let's just say. And then I'm going to go down and give an estimate of where that's at. So I go over, I hit my graph, I go down, and my estimate doesn't have to be perfect, it just needs to be, in the ballpark. I'm going to say would be, what do I say, maybe like 72 inches. So that would mean, so that would be my estimate, and the interpretation of that is, again, I'm interpreting the 80th percentile. So what that means is 80% of the students are 72 inches or less or below. Maybe in height. So their height, not the best sentence, but their height, 80% of students are at least 72% or 72 inches or less in height. So percentile just means at that number or below, that is that value. So creating one of these graphs, which I want to create the graph in the best way I can. It might not be perfect, but that's where it's at. So, okay, so this is that COVID-19 cumulative frequency graph I was actually talking about. So this is from like last week from KBTX. They post daily our COVID-19 numbers. And so I was looking at them, and they have a ton of graphs. And so this blue and yellow lines are cumulative frequency graphs. This green one is not cumulative frequency. It is, well, it actually is, but people are, yeah, no, this one's not cumulative. This would just be like an active case, and then, okay, there's not as many active. But these two up here are cumulative frequencies. So our total amount of cases that we've had, they started with 0, and we slowly started having some, and we had more and more and more. And so these active cases, when we had an active case here, it added to this number. When I had all of these active cases, the biggest number, they added this range, and they took it up here and added it to the total. So they took this green graph, which would be just like, this would just be a frequency graph, and they made these the cumulative frequency. So they just stacked up, and they stacked up, and they stacked up. And so, of course, at this point, which was October 1st, we have about 5,000 total cases in our Brazos County. But it doesn't mean that we have 5,000 active cases today. It just meant from beginning to end, we have 5,000 cases. And this amount have recovered by then, and all these people are either actively have cases or others. So this is just an example of real life cumulative frequency. Sometimes I don't personally like the use of cumulative relative frequency, because if I just gave you this blue graph here and told you, look at how many cases we have, someone would be like, oh my goodness, we have 5,000 cases right now. When in reality, our active cases is at about like 500. But if I just gave you this blue graph, you might think that we're at 5,000. So just knowing how to read a graph right, it's not a bad graph, it's just using it correctly and not giving people the wrong ideas. Okay, so some important ideas, some big ideas. So the first one would be, we're going to talk about two things, percentile and cumulative frequency. So the percentile, the big one here, would be the percent of values that are less than or equal to a given value. So your value, whatever it is. Okay. So the percent of values that are less than or equal to a given value. So your number, and then all the ones that are less than. And then the other one, we have the cumulative relative frequency graph. That is a long thing to write. Okay, so cumulative relative frequency graph. Some main points. So we've got starting at 0, and then we're ending at 100% of our data. We've got our little like histogram tick marks, and our graph could start here and it goes up a certain amount. Sometimes it goes up a lot. Then I could have not a lot of values, and then end up, though, I'm going to end up at that 100% by the end of it. So seeing the graphs between them. So main thing, if these are our percentiles, well, we'll go through that. So this is our cumulative frequency. I'm going to add through there. So this would mean little values through there. This would mean, this little section would mean there were a lot of values through those two. And then also the percentages over here can be our percentiles. So this is kind of a graph. This is a way to graph percentiles. Okay, so let's get some practice on that using some stuff. So to check your understanding, Miss Munson is concerned about her daughter's height and weight compared to those of her same age. She uses an online calculator and determines that her daughter is in the 87th percentile for weight and 67th percentile for height. Explain to her what those values mean. So 87th percentile for weight. So that would just mean she's doing pretty good in the weight category. She is 87% of girls. So girls, you could even say like girls her age, because like I'm not comparing my 2-year-old daughter to like a 15-year-old girl. I'm comparing my 2-year-old to a 2-year-old and a 3-year-old to a 3-year-old. So 87% of girls her age have a weight less than or equal to her daughter. And then the same for her height, 67th percentile, so that would just be 67% of girls her age have a height that is less than or equal to her daughter. So she's pretty tall. Well, just taller than average. Okay, so let's less than or equal to your daughter. All right, number 2, cumulative frequency graph is displaying the length of phone calls made from the mathematics department at the high school last month. So our call length, and then here's our cumulative frequency. We end at 100%, so this is at our 100%, and we started at 0%. Okay, about what percent of calls lasted less than 30 minutes? And then another question, 30 minutes or more. So at 30 minutes would be here. So what percent lasted less than 30 minutes? So if I kind of come up to that 30-minute number, and then I do my best to kind of flat draw this, the best flat line I've ever drawn. That was pretty good. I've got, I'm gonna say about 65. So what percent? I'm gonna say 65% less than, which would then be 35% more. Okay. So if I was to, again, if I was to say that that number was 65, what I'm saying is maybe this should actually be less than or equal to, because this little number that I got here, all of these values over here can be known as our percentiles. So that 30th person would be in the 65th percentile, is what that would be. So 65% are less than or equal to. Okay, one thing with a cumulative frequency graph that they like to do as well is they'll maybe ask you, like, where's the 30-minute call at? Where's the 80th percentile? Or they might ask you for like the IQR or the median or the 5-number summary. So this is part B, so maybe on a different page here. So maybe I'll do, so part B, let's do the 5-number summary. I know on B it just says the Q1 and the Q3, but let's just do them all. So the 5-number summary, from the graph, I want to get what is the minimum number, what is the Q1, what is the median, what is the Q3 number minutes of calls, and what is the maximum number minutes call length that we had. So a couple easy ones would be the minimum and the maximum. So here I am here at 0. So what I'm going to say is if we had 0 here and this was our first kind of tick mark, I'm going to say that from this range there was some sort of number, I don't know where, so I'm just going to say 0 was our minimum. And then the same thing here, there's a range of values that was a max, so I'm just going to go with like 42 being the max. So I'm going to say the minimum was 0 minutes and the max was 42 minutes, because those are kind of ranges. Okay, so if I wanted to do the Q1, the median, and the Q3, so let me think about these first. So the median is if I line up all my numbers in a row and I got the middle number. So that would be like the 50% of my data. The Q1 is the median of the first half. So I split my number in half and get the middle of that, which is 25%. And the Q3 is the median of the second half, so the 75% mark. So what I'm looking for with these is I'm looking for the 25th percentile, the 50th percentile, and the 75th percentile, because those are the percents that's less than or equal to Q1, median, and Q3. So if I go back, maybe let's do our Q1 first. So let me get a rough estimate here. Like this is the 25% mark. So I'm looking for the 25th percentile. So to my best of my ability, I'm just gonna draw a straight line over, which that one was okay. Then I'm gonna come down and something like 13 or 14. So if you're plus or minus like 1 or 2, I think you're okay on guesses there. So maybe I'll say, maybe I'm feeling 14 minutes there with my drawing. So I'm gonna say 14 minutes. If you ended up saying 13, you'd probably be good. 15 is probably too much just based upon that graph. But that would be, the Q1 would be at the 14 minute mark. So I'm saying that's the number 14. You could probably say 13, but I'll just say that. Okay, what if I got the median? So the median is the 50th percentile. So I'm gonna say that that is about 50. So I'm gonna do my best again to go straight over. That's a pretty decent line. It's probably on that dot is the 50. And what are we saying? Maybe that's 18. So on the last one I said 14, maybe I'll go with the lower one. So I'll say 18 is the median. So 18 minutes is our median. And then the 75th percentile would be up here. So that would be the 75th percentile. I'm gonna go straight over, which is pretty decent there, and straight down. And I'm gonna say 32. I think that's pretty decent. So maybe that would be equal to 32 minutes. So then I can give anything you kind of want. So question B was asking for the Q1 and the Q3, and it also asked for the IQR. So the IQR is the range from Q3 to Q1. So from 32 minutes to 14 minutes. So I'm going to say that our IQR is equal to 18 minutes. And if you had like 19 or maybe 17, something around there, I think there is wiggle room because it's our best estimate. If you just can't draw a straight line at all and you're like 5 points off, 5 minutes off, then I think you'd be counted wrong. But just to the best of our ability, where's that estimate at? So they do like to use cumulative frequency graphs in this way to kind of ask you, like, where's your Q1? Where's your Q3? What's your IQR? Where's the median? So knowing how to read our cumulative frequency graph, and that these numbers on the sides are just percentiles, because if our graph is cumulative, those are just adding on top of each other, and it is a just a percentile number on that left side. Okay, and if you need to pause, go back, watch, please do. It'd be good. One other thing to note is this is not a question, but our graph has a slow start, then it has a lot of values, then it has a slow start, a lot of values, and then a slow start again. So let me just do something like, let me just give a rough estimate here for a histogram. Let's say I made a histogram for this. So what that would mean in this first section, I didn't have a lot of values, and then I maybe had some more. I started increasing, so like through here, I started increasing. Then in this little section here, I really got a lot. So I'm gonna say that this one went really steep. So I probably had a really big histogram and then another pretty steep one. So, but it kind of flattened off, and then I flattened off some more. So maybe that little section there looks more like this. But then in this little section here, it was basically flat. So if anything, there's like maybe nothing for a little bit. And then in this next little section, it really increased. So maybe I came back up for a little bit and then it stopped. So there were few numbers. So our data would be small, big, small, and then big again. So it kind of had a bimodal, it went up and down. So sometimes they talk about reading graphs like that too. So the homework talks about, it has some questions about reading a cumulative frequency graph as well. So just knowing how to read it, get the IQR, get the percentiles, get estimates from the 65th percentile, whatever. Just all different ways of knowing how to read a percentile graph.